The year was 1942. The world was burning. From the frozen steppes of Russia to the sun-scorched sands of North Africa, from the dark waters of the Atlantic to the endless blue expanse of the Pacific, humanity had plunged itself into the most devastating conflict it had ever known. And in the midst of this chaos, in a small, cramped office in Derbyshire, England, a young engineer named Stanley Hooker was about to be called an idiot. But we're getting ahead of ourselves. To understand how one man's supposedly foolish idea would help turn the tide of the war, we need to go back. Back to a time when Britain stood alone against the darkness, when every drop of fuel was more precious than gold, and when the fate of nations hung on the performance of engines screaming through the sky at 300 miles per hour. The rain hammered against the windows of the Rolls-Royce factory in Derby on that gray morning in March. Inside, the air was thick with cigarette smoke and the acrid smell of machine oil. Men in grease-stained overalls moved between rows of partially assembled engines, their faces drawn with exhaustion. They had been working 12-hour shifts, sometimes longer, racing against time itself. These weren't just any engines. These were Rolls-Royce Merlins, the beating heart of the Supermarine Spitfire, the soul of the Hawker Hurricane, the power behind the Avro Lancaster bomber. Every single one of these magnificent machines that rose into Britain's gray skies carried a Merlin within its frame, and every single one of those Merlins was drinking fuel like a man dying of thirst. Stanley Hooker stood at his desk, staring at the technical drawings spread before him. At 30 years old, he was considered young for such a senior position. His colleagues saw him as brilliant but theoretical, a Cambridge mathematician who understood aerodynamics better than most, but who sometimes seemed to exist in a world of pure numbers rather than the harsh reality of metal and fuel and fire. The knock on his door was sharp, urgent. "Hooker, conference room, now." It was Ernest Hives, the works manager, a man who had started his career as an apprentice and worked his way to the top through sheer determination and an almost supernatural understanding of engines. He was not a man you kept waiting. The conference room was already full when Stanley arrived. Senior engineers, military liaisons, even a representative from the Ministry of Aircraft Production. The tension in the room was palpable, thick enough to cut with a knife. Hives stood at the head of the table, his face grim. "Gentlemen, we have a crisis. As you all know, our bombers are struggling to reach their targets in Germany, not because of enemy fire, not because of mechanical failures, but because they're running out of fuel before they can complete their missions and return home." He paused, letting the weight of his words sink in. "The Lancaster can carry 10 tons of bombs. It can fly for over 2,000 miles. But to bomb Berlin and make it back to England, it needs every last drop of fuel in its tanks. And right now, we're losing planes, not to flak, not to fighters. They're simply running dry over the North Sea and going down." The silence that followed was heavy. Everyone in that room knew what happened to crews that ditched in the North Sea. The freezing water gave a man perhaps 15 minutes before hypothermia claimed him. Even if the crew survived the crash, rescue was far from certain. Men simply disappeared into that gray, indifferent sea. "We've tried everything," Hives continued. "We've reduced bomb loads, we've stripped out guns and armor, we've even experimented with filling every available space in the aircraft with extra fuel tanks. Nothing works. We need more range, and we need it yesterday." One of the senior engineers, a gray-haired man named Rubra, spoke up. "What about developing a new engine, something more efficient from the ground up?" Hives shook his head sharply. "Development would take years. Testing, certification, production tooling. We don't have years. We might not even have months. Germany is building their industrial capacity. Their rocket program is advancing. If we can't strike their factories, their oil refineries, their submarine pens, we'll lose this war." "What about modifying existing engines?" another voice asked. "We've tried. Everything we do either reduces power output or increases weight. There's no magic solution." Stanley had been silent throughout the meeting, his mind racing through equations, airflow dynamics, compression ratios. The Merlin was already one of the most efficient engines of its type. Squeezing more range out of it seemed impossible. The laws of physics were unforgiving, but then, as Hives began discussing operational changes and mission planning alternatives, something clicked in Stanley's mind. A memory from his university days, a lecture on supercharger efficiency. The professor had mentioned something almost as an aside about how the angle of impeller blades affected not just air pressure, but fuel consumption. "What if we changed the supercharger?" Stanley heard himself say. The room went quiet. All eyes turned to him. Hives frowned. "The supercharger works fine, Hooker. It's one of the most reliable components we have." "I'm not talking about reliability," Stanley said, standing up and moving to the blackboard at the front of the room. "I'm talking about efficiency. The current impeller design is optimized for maximum boost pressure. But what if we're approaching this wrong? What if we accepted slightly lower boost at high altitude in exchange for dramatically better fuel efficiency?" He began sketching on the board, curved lines representing airflow, angles showing blade geometry, numbers calculating pressure differentials. The current impeller blades are set at a relatively aggressive angle. They're designed to cram as much air as possible into the combustion chambers, but in doing so, they create turbulence, wasted energy, heat that dissipates instead of driving the aircraft forward. Rubra stood up, studying the equations. "If you reduce the blade angle, you'll lose power." "At sea level, yes," Stanley agreed, "but at 20,000 feet, where our bombers operate, the air is already thin. The current aggressive angle is actually creating more problems than it solves. The engine is working harder than it needs to, burning more fuel to overcome the inefficiencies in the supercharger itself." He drew another diagram showing modified blade angles. "If we shallow out the blade angle by approximately 12 degrees, we reduce the turbulence in the airflow. The supercharger doesn't have to work as hard, the engine runs cooler, and, most importantly, we could see fuel consumption drop by as much as 25 to 30% at cruising altitude." The room erupted. "That's insane," someone said. "You can't just change the blade angle," Rubra argued. "The entire supercharger is designed around those specifications. You'd destroy the engine." "The metallurgy alone would take months to recalculate," another engineer added. But Hives was staring at the blackboard, his eyes narrow with thought. He had spent his entire life around engines. He understood them not just intellectually, but intuitively. And something in Stanley's proposal resonated with that deep instinctive knowledge. "How sure are you?" Hives asked quietly. Stanley met his gaze. "Mathematically, the theory is sound. But I won't lie to you, sir. There's only one way to know for certain. We'd have to build it and test it. And if you're wrong, then we've wasted time and resources we can't afford to waste." Hives was silent for a long moment. Outside, the sound of aircraft engines warming up echoed across the factory grounds. Young men climbing into cockpits, heading out into harm's way. Some of them would not return. "Build a prototype," Hives said finally. "You have 1 week." The room exploded in protests, but Hives raised his hand for silence. "1 week, Hooker. If this works, you'll be a hero. If it doesn't, well, we'll deal with that when we come to it." Dismissed. As the room emptied, Stanley stood alone at the blackboard, staring at his equations. 1 week, 7 days to do what should take months. 7 days to reshape metal and test theories and possibly save thousands of lives. Or to fail spectacularly and be remembered as the mathematician who thought he knew better than the engineers. He picked up his papers and headed for the machine shop. The head machinist was a man named George Davies, 50 years old, built like a barrel, with hands that could shape metal with the precision of a surgeon. He looked up from the engine block he was working on as Stanley approached. "Mr. Hooker," he said, wiping his hands on an oily rag. "What can I do for you?" Stanley spread his drawings on the workbench. "George, I need you to modify a supercharger impeller. Change the blade angle by 12 degrees. George studied the drawings, his face unreadable. Then he looked up at Stanley with an expression that mixed disbelief and concern. "You want me to do what now?" "I know how it sounds." "Do you, though?" "Because it sounds bloody stupid, if you'll pardon my French. Those impellers are precision instruments. You can't just file down the blades and hope for the best." "I'm not suggesting we file them down," Stanley said patiently. "I'm suggesting we machine new ones, from scratch, with the modified angle built in from the start." George let out a low whistle. "That's weeks of work, maybe months." "We have 1 week." "1 week? To machine new impeller blades? Mr. Hooker, with respect, I don't think you understand what you're asking." "I understand perfectly. I'm asking you to do the impossible. Because if we don't, men are going to die. Good men, brave men. They're going to run out of fuel over the North Sea and disappear beneath the waves, and we're going to read their names in the casualty lists and wish we'd done more." George was silent for a moment. Then he nodded slowly. "All right, I'll need my best men, and we'll need to work round the clock. You'll have whatever you need. And if this doesn't work, if we wreck this engine—" Stanley met his eyes. "Then it's on me, not you." "Me?" George grunted. "Fair enough. Let's get started." What followed was 7 days of pure, unrelenting effort. George and his team worked in shifts, the machine shop running 24 hours a day. The whine of lathes and mills became a constant soundtrack. Metal shavings piled up on the floor like silver snow. Men snatched sleep in chairs, woke up, and immediately returned to work. Stanley barely left the factory. He had a cot set up in his office, though he rarely used it. Instead, he spent his nights in the machine shop, watching the impeller take shape, checking measurements, recalculating stress factors. Coffee and cigarettes became his primary sustenance. On the 3rd day, there was a setback. One of the blades cracked during machining. The stress of cutting at the new angle had found a flaw in the metal. They had to start that blade over from scratch, losing precious hours. On the 5th day, word spread through the factory about what they were attempting. Other engineers came by to watch, some curious, most skeptical. The phrase "Hooker's folly" began circulating. Bets were quietly made about whether the modified engine would even start, let alone run properly. Stanley ignored it all. He had committed to this path, and there was no turning back now. On the morning of the 7th day, George Davies emerged from the machine shop carrying the completed impeller. It gleamed under the factory lights, every blade perfectly angled, every surface polished to mirror brightness. It was beautiful. It was also completely untested. "She's ready," George said simply. "God help us all." They installed the modified impeller in a test engine that afternoon. A crowd gathered as Stanley and the senior engineers prepared for the first run. Hives stood to one side, his face unreadable. Rubra was there too, arms crossed, clearly expecting disaster. The engine was mounted on a test stand, connected to instrumentation that would measure every aspect of its performance: fuel flow, air pressure, temperature, power output. Everything would be recorded, analyzed, dissected. Stanley stood at the control panel, his hand on the starter. His mouth was dry. 7 days of work, thousands of pounds spent, his entire career, all coming down to this moment. "Ready?" he asked the technician, monitoring the instruments. "Ready, sir." A fee. Stanley pressed the starter. The Merlin coughed once, twice, then caught with a roar that shook the building. The propeller on the test stand began to spin, slowly at first, then faster, becoming a blur. The sound was glorious, that deep, powerful note that every British pilot knew and loved. But the real question wasn't whether it would run. The question was whether it would run efficiently. Stanley watched the instruments. Fuel flow rate. There. The numbers were scrolling across the gauge. He did the calculation in his head, comparing it to the baseline data they'd recorded before the modification. His eyes widened. "What's it showing?" Hives called over the engine noise. Stanley looked up, his face pale. 28% reduction in fuel consumption at cruising RPM. The machine shop went silent, except for the roar of the engine. 28%. Not the 30 he'd promised, but close enough. More than close enough. "Run it up to full power," Hives ordered. They pushed the throttle forward. The engine note changed, climbing in pitch, becoming a scream. The power output gauge climbed. 1,500 horsepower, 1,600, 1,700. "Power output is only down by 3%, the technician called out. "Well, within acceptable parameters." Rubra moved closer to the test stand, staring at the spinning propeller as if he couldn't quite believe what he was seeing. Other engineers began checking the instruments, verifying the readings, looking for some error, some mistake that would explain these impossible numbers. But there was no mistake. The modified engine was performing exactly as Stanley had predicted. Better, even. They ran the engine for 3 hours straight, putting it through every conceivable test. Full power, cruising power, rapid throttle changes. The results were consistent. 28% better fuel efficiency with minimal loss of power. When they finally shut the engine down, the silence seemed deafening. Hives walked slowly to where Stanley stood, still staring at the data sheets in his hands. "You did it," Hives said quietly. "You actually did it." Stanley looked up, and for the first time in 7 days, he smiled. "We did it. Me, George, his team, all of us." Hives nodded. Then he raised his voice so everyone in the machine shop could hear. "Gentlemen, I want these modifications on every Merlin engine in production, starting immediately. I don't care if you have to work around the clock. I don't care about the cost. This is now our highest priority." The implications were staggering. 28% better fuel efficiency meant Lancaster bombers could reach targets deep in Germany and return safely. It meant fighters could patrol longer, covering more of the channel. It meant fewer planes lost to fuel starvation, fewer crews lost to the sea. It meant lives saved, missions completed, progress in a war that had dragged on too long. But as the crowd began to disperse, as congratulations were offered and backs were slapped, Rubra pulled Stanley aside. "I'll admit it," he said grudgingly. "I thought you were crazy. I thought this whole thing was a waste of time, but you proved me wrong." "Thank you," Stanley said. "Don't thank me yet," Rubra continued, his expression serious. "Because now comes the hard part. Production, training, making sure every single one of these modified engines meets spec, and dealing with the pilots who are going to be very nervous about flying with what they'll see as experimental equipment." He was right, of course. The technical challenge was only the beginning. Now came the human challenge, convincing the Royal Air Force that this modification was safe. Getting it through certification, ramping up production without disrupting the existing supply line. 100 small crises waiting to happen. But Stanley had faced down the impossible once. He could do it again. The next few weeks were a whirlwind. The modified impellers went into production. Existing engines were retrofitted during routine maintenance. New engines rolled off the assembly line, with the improvements built in from the start. George Davies and his team trained other machinists in the precise techniques needed to create the modified blades, and slowly, gradually, the reports began coming in from the front lines. A Lancaster squadron based in Lincolnshire completed a bombing run to Hamburg and returned with fuel to spare. Previously, that same route had required them to throttle back to dangerous speeds to conserve fuel. Now they could maintain proper formation, defend themselves more effectively. A Spitfire pilot over the channel reported he was able to extend his patrol time by nearly 40 minutes. 40 precious minutes that meant more coverage, better protection for the convoys struggling across the Atlantic. A Hurricane squadron in North Africa found they could now reach targets that had previously been just beyond their range. The fight against Rommel's forces gained a new dimension. The numbers were undeniable. Fuel consumption across Bomber Command dropped by an average of 26%. The number of aircraft lost to fuel starvation fell to nearly zero. Mission success rates improved. Pilot confidence soared, and Stanley Hooker, the mathematician they'd once called crazy, found himself being summoned to the Air Ministry in London. The train from Derby to London seemed to take forever. Stanley sat in a first-class compartment courtesy of Rolls-Royce, watching the English countryside roll past. It was spring now. The fields were green. Flowers bloomed in cottage gardens. It was easy, on this peaceful journey, to forget that England was still at war. At the Air Ministry, he was ushered into a conference room far grander than the one in Derby. Wood-paneled walls, portraits of distinguished air marshals from wars past, a long table polished to a mirror shine. Air Marshal Arthur Harris sat at the head of the table. Bomber Harris, they called him, the man responsible for the strategic bombing campaign against Germany, a man with the weight of thousands of lives on his shoulders. "Mr. Hooker," Harris said as Stanley entered, "please, sit." Stanley sat, acutely aware of the other officers in the room. Squadron leaders, wing commanders, men who had flown combat missions, who had seen friends burn and fall. Harris leaned back in his chair, studying Stanley with sharp eyes. "I've been reading the reports about your engine modification. Quite extraordinary. 28% improvement in fuel efficiency. Do you know what that means, Mr. Hooker?" "It means longer range, sir." "It means more than that. It means we can hit targets we couldn't reach before. It means we can carry more bombs and still make it home. It means the difference between a strategic bombing campaign that merely annoys Germany and one that actually cripples their war machine." He paused, letting that sink in. "I've authorized the expansion of bomber production. We're going to build more Lancasters, more Halifaxes, and every single one of them will have your modified Merlins. By this time next year, we'll have the capability to strike anywhere in occupied Europe. Berlin, Hamburg, the Ruhr Valley, nothing will be beyond our reach." Stanley felt a chill run down his spine. Pride, yes, but also a terrible weight. Because he understood what Harris was really saying. More bombers meant more raids. More raids meant more destruction, more casualties on both sides. "I know what you're thinking," Harris said quietly. "You're thinking about the cost. The cities will burn, the lives will take. And you're right to think about it. War is a monstrous thing, but the alternative is worse. If we don't break Germany's ability to wage war, this conflict will drag on for years. Millions more will perish. Sometimes, Mr. Hooker, the moral choice is the one that ends the suffering soonest, even if the path there is dark." Stanley had no answer to that. He was an engineer, not a philosopher. He built things, he solved problems. The uses to which his solutions were put, the grand strategy of war. That was beyond his purview, but it weighed on him nonetheless. "There's one more thing," Harris continued. "Your work hasn't gone unnoticed at the highest levels. The Prime Minister himself has been briefed. There's talk of a commendation, possibly a knighthood after the war." Stanley shook his head. "That's not why I did this, sir." "I know, but we honor those who serve, Mr. Hooker, in uniform or out of it. You've done more to advance our cause than many men who've fired a gun." The meeting concluded shortly after. Stanley was given a tour of the Air Ministry's operations room, where the nightly bombing raids were planned. He saw maps covered in pins, charts tracking aircraft availability, fuel reserves, bomb stocks, the vast, complex machinery of modern warfare. It was humbling and terrifying in equal measure. On the train back to Derby, Stanley found himself thinking about those early days in the machine shop, the smell of hot metal, George Davis's rough hands shaping impeller blades, the sound of the first test run. It had all seemed so simple then. An engineering problem, a solution. Numbers on paper becoming reality. He hadn't thought about the bombers those engines would power, the cities they'd attack, the people below who would hear the air raid sirens and rush to shelters, praying their home would be spared. The train rattled through a small station without stopping. Stanley caught a glimpse of the platform. A young woman in a WAF uniform, waiting, probably heading to her posting, probably somebody's daughter, somebody's sweetheart, putting herself in harm's way for king and country. That's what it was all about, Stanley realized. Not the grand strategy, not the politics, not even the engineering elegance of a well-designed impeller. It was about that girl on the platform, about giving her and millions like her a chance to live in a world free from tyranny. Back at the Rolls-Royce factory, work continued apace. The modified Merlins were now standard production. George Davies had been promoted to chief machinist. His team had grown to include dozens of skilled workers, all trained in the precise techniques required for the new impeller design. Stanley threw himself back into his work with renewed vigor. The supercharger modification was done, proven, in production. But there were always more problems to solve, more improvements to make. The Merlin Mark XX was in development, with plans for even higher altitude performance. The new Griffin engine was showing promise for the next generation of fighters. The war ground on. 1943 became 1944. The Allies landed in Normandy. The Russian armies pushed westward. The bomber offensive intensified, 1,000 plane raids becoming routine. And through it all, Stanley's modified Merlins roared through the skies, their improved efficiency helping to turn the tide. It was in the spring of 1945, as Germany's defeat became inevitable, that Stanley received a visitor, an American colonel assigned to the U.S. Army Air Force's Technical Evaluation Team. "Mr. Hooker," the colonel said, shaking his hand, "Colonel Mike Harrison, I've been studying your supercharger modifications. Brilliant work." "Thank you, Colonel. How can I help you?" "I'm here to talk about the Pacific. As you may know, we're still locked in a brutal fight against Japan. Distance is our biggest enemy out there. Island-hopping campaigns mean our bombers need every bit of range they can get." Stanley nodded, understanding where this was going. "We'd like to license your modification for American engines, the Allison V-1700 specifically. It powers our P-38 fighters. If we could get the same kind of fuel efficiency improvements you achieved with the Merlin." "It should be possible," Stanley said. "The principles are the same. You'd need to adjust for the differences in engine displacement and supercharger design, but the fundamental concept translates. They spent hours going over technical drawings, discussing implementation strategies. By the end of the day, an agreement had been reached. Stanley would travel to America, work with Allison's engineers, help them adapt the modification for their engines. It meant more travel, more time away from home, more stress. But it also meant more lives saved, more missions completed, a quicker end to the war. 3 months later, the first modified Allison engines entered service with the 5th Air Force in the Philippines. The results were just as dramatic as they'd been with the Merlins. P-38 fighters could now escort bombers all the way to targets in Japan and back. The strategic bombing campaign against Japanese industry intensified. And then, in August of 1945, everything changed. 2 American B-29 bombers flying from Tinian dropped atomic weapons on Hiroshima and Nagasaki. Japan surrendered days later. The war was over. Stanley was back in England when the news came. He was in his office at Rolls-Royce, working on designs for a new generation of jet engines. The factory whistle blew long and loud. People poured out of the workshops, cheering, crying, embracing. The war was over. They had won. That night, Stanley walked through the factory one last time. It was strange seeing it quiet. No engines running on test stands, no machining sounds, just silence and shadow. He found himself in the machine shop where it had all started, where George Davies and his team had worked around the clock to machine those first modified impellers. The place looked different now, cleaner, more organized, but the memories remained. Stanley stood there, remembering that frantic week. The doubt, the skepticism, the moment when the modified engine first roared to life, the impossible made real through determination and skill and a willingness to try something new. He thought about all the young men who'd flown with those engines, the ones who'd made it home, the ones who hadn't. He wondered how many lives his modification had saved. Hundreds? Thousands? There was no way to know for certain. No way to count the bombers that had landed safely instead of ditching in the sea, the fighters that had made it back to base instead of running out of fuel over enemy territory. George Davies found him there, standing in the shadows. "Evening, Mr. Hooker," George said. "Couldn't sleep either?" "Just thinking," Stanley replied, remembering. "Aye, it's been quite a journey, hasn't it? When you first came to me with those drawings, I thought you'd lost your mind. 12-degree angle change on the impeller blades. Bloody madness, I thought. But you did it anyway. Well, you made a convincing argument, and I figured if it didn't work, at least we'd have a good story to tell in the pub." He paused. "Never imagined it would turn out like this, though. Never imagined our little modification would end up in thousands of engines helping win the war." "It wasn't just us," Stanley said. "It was everyone. The assembly workers, the test pilots, the ground crews, every person who played a part." "True enough, but it started here, in this shop, with your crazy idea and my even crazier willingness to try it." They stood in comfortable silence for a moment, two men who had been through the fire together and emerged on the other side. "What will you do now?" George asked. "Now that the war's over?" Stanley smiled. "Keep building engines, I suppose. That's what I do, though hopefully for more peaceful purposes." "Jets, I heard. You're working on jets." "The future of aviation. Someday, George, passenger planes will fly faster than the speed of sound. They'll cross the Atlantic in hours instead of days, and maybe, if we're lucky, the engines we design will power that future." George chuckled. More crazy ideas from Mr. Hooker. Some things never change. But they had changed. Everything had changed. The world had been through hell and emerged transformed. Old empires were crumbling. New superpowers were rising. Technology had advanced at a pace that would have seemed impossible just 6 years earlier. Radar, jets, computers, and yes, atomic weapons. Humanity had unlocked terrible powers and would now have to learn to live with the consequences. And in the midst of all that world-shaking change, a small modification to an engine's supercharger might seem trivial. Just a footnote in history, a technical adjustment that happened to come at the right time. But Stanley knew better. He knew that wars weren't won by grand gestures alone. They were won by thousands of small improvements, each one giving your side a tiny advantage. Those tiny advantages accumulated, compounded, until they became decisive. 28% better fuel efficiency didn't sound like much, but multiply that across thousands of aircraft, millions of flight hours, and suddenly it was the difference between victory and defeat, between a strategic bombing campaign that merely damaged Germany and one that broke its ability to wage war, between pilots who made it home and pilots lost forever to the gray waters of the North Sea. In the years that followed, Stanley Hooker would indeed go on to work on jet engines. He would become one of the pioneers of British aviation technology. The Rolls-Royce Avon, the Conway, the legendary Pegasus that powered the Harrier jump jet. His fingerprints would be all over the engines that powered British aviation through the second half of the 20th century. He would receive his knighthood, becoming Sir Stanley Hooker. He would write memoirs, give lectures, mentor young engineers. He would live to see men walk on the moon, powered in part by technology he helped pioneer. He would see the Cold War come and go, see supersonic passenger flight become routine, see computers shrink from room-sized monsters to devices that fit in a pocket, and, through it all, Whenever young engineers asked him about his greatest achievement, he would always come back to that week in 1942. 7 days when the impossible became possible, when a crazy idea became reality, when mathematics and metalwork combined to create something that helped save lives and end a war. People called it stupid, he would say, always with a slight smile. Hooker's folly, they called it. Said I was wasting time and resources. Said the modification would never work, or worse, would damage the engines. And maybe they had reason to be skeptical. It was a radical change based on theoretical calculations. We had no guarantees it would work. Then he would pause, letting the suspense build. But sometimes the stupid idea is the one that works. Sometimes what looks like folly turns out to be genius. The trick is being willing to try, being willing to challenge assumptions, being willing to look at a problem everyone thinks is solved and ask, but what if we approached it differently? That philosophy would define his entire career. When everyone said jet engines were too unreliable for commercial aviation, he helped make them reliable. When everyone said vertical takeoff was impractical, he helped design the engine that made it possible. When everyone said supersonic passenger flight would never be economically viable, he helped prove them wrong. But that first breakthrough, that supercharger modification, would always hold a special place in his heart, because it taught him the most important lesson of all. That innovation often looks stupid right up until the moment it works, that the gap between crazy and brilliant is measured not in the idea itself, but in the courage to try and the skill to execute. George Davies understood that too. He would go on to train an entire generation of machinists, passing on not just technical skills, but a philosophy of craftsmanship and dedication. The men he trained would build engines for decades to come, always mindful of the standards he set during those desperate war years. And sometimes, late at night in the machine shop, when the younger workers asked how he managed such precision work under such intense pressure, he would tell them about that week in 1942. About the crazy mathematician with the radical idea, about working around the clock, powered by nothing but coffee and determination, about the moment when that modified engine first roared to life and they realized they had done something extraordinary. Mr. Hooker had faith in his calculations, George would say, and I had faith in my ability to execute them. Together, we made something that worked. That's the secret, really, having the vision to see what could be, and the skill to make it real. The modified Merlin engines served throughout the rest of the war. After the war, many were refurbished and continued in service for years. Some powered civilian aircraft. Some were used for training. A few ended up in museums where visitors could see the slightly modified impeller blades that had made such a difference. If you looked closely, you could see it. That 12-degree angle change, such a small difference in the metal, such a huge difference in performance. Engineers would study those impellers in the decades that followed, using them as teaching examples. This, professors would say, is what innovation looks like, not some flashy, dramatic redesign. Just a small, carefully considered change based on solid mathematical principles. But that small change saved fuel, extended range, and helped win a war. The bomber crews who flew with those engines never knew about Stanley Hooker. They never knew about the week of frantic work in a Derby machine shop. They just knew that their Lancaster could make it to Berlin and back, that their Halifax could reach the Ruhr Valley and still have fuel to spare, that when they pointed their aircraft toward home after a long, dangerous mission, they could trust their engines to bring them safely back. And that trust, that reliability, was worth more than all the medals and honors Stanley would ever receive. On a spring morning in May of 1945, a Lancaster bomber made its final approach to a base in Lincolnshire. The pilot, a young flight lieutenant named Davies, no relation to George, pulled back the throttle and brought the big aircraft in for a smooth landing. It had been his 30th mission. Under RAF rules, 30 missions meant his tour was complete. He could go home. As he climbed out of the cockpit, Davies patted the side of the fuselage affectionately. This Lancaster had brought him through flak and fighters, through weather and equipment failures, and most importantly, it had always had enough fuel to get home. He would never know that the reason for that reliability sat inside those 4 Merlin engines. Would never know about a mathematician's radical idea and a machinist's skill in executing it. Would never know about the week that changed aviation history. But he would go home to his family, would live to see his children grow up in a world at peace, would tell stories about his war years, about the friends he'd lost and the missions he'd survived. And in the background of all those stories, unmentioned but always present, would be the quiet hum of those modified Merlins, carrying him through the darkness and safely home. That, in the end, was what it was all about, not the engineering triumph, impressive as it was, not the cost savings or the extended range or the improved mission success rates. It was about the young men and women who risked everything for a cause they believed in, the ones who climbed into their aircraft day after day, night after night, knowing that every mission might be their last. Stanley's modification gave them a better chance, not a guarantee. War provides no guarantees, but a better chance. A few extra gallons of fuel, a few extra miles of range, the difference between ditching in the North Sea and making it to the English coast. The difference between coming home and never being seen again. And if you measure the value of an innovation not in technical elegance or mathematical precision, but in lives saved and futures secured, then that 12-degree angle change in a supercharger impeller was one of the most important modifications in aviation history. The stupid idea that wasn't stupid at all. The folly that turned out to be brilliance. The week that helped win the war. That's the story of how one engineer's supposedly crazy engine modification cut fuel use by 30% and helped change the course of history. It's a story about having the courage to challenge conventional wisdom, about the importance of backing up radical ideas with solid math and careful execution, about the value of skilled craftsmen who can turn theory into reality. And most of all, it's about the thousands of small innovations that, taken together, won the greatest conflict humanity has ever known. So the next time someone calls your idea stupid, remember Stanley Hooker. Remember that week in Derby. Remember that the gap between folly and genius is often just one successful test. And remember that the best innovations often look impossible right up until the moment someone makes them work. The war ended. The engines kept running. And somewhere in the skies over England, if you listened carefully, you could still hear the sound of those modified Merlins, their efficiency improved, their range extended, carrying their crews safely home through the gray clouds of a world slowly emerging from darkness into light. That sound, that reliable, powerful roar, was the sound of innovation, the sound of dedication, the sound of one man's crazy idea becoming thousands of men's salvation. And it all started with a 12-degree angle change that everyone said was stupid until it worked.